So here's an example of a force being applied at an angle and how we'll rectify that to figure out exactly what the force is, the net force being applied to this box as it slides across. So we have a 50 Newton box. It's being pulled across a frictionless surface, so we don't care about friction. And it's pulled at a 30-degree angle to the horizontal. And we'll give this some force. We'll say, I don't know, 80 newtons. So the question is, what is the sum of the forces in the x direction? So what we're going to do is I'm going to draw this free body diagram. So let's pull it out. So I have a box. I have the force of the earth on the box, earth on box, and then I'll have the normal, since it's sitting on a surface. So the normal of the floor or the surface on the box, and then I have this angled pull on it. So this is the force of the, or we would say the tension, since it's the rope, the tension of the rope on box. And what I want to know is since there's no friction, there's no other component over here, there's no other force being applied, I want to know the x component of this tension. These two, if I sum them, would be 0. So I have a little piece of vertical from the tension, but all I care about is the x. So let me redraw just that vector. So there's my tension vector. And now we'll get our, so I'll have this one, I'll have my tension in the x direction and my tension in the y direction. And these are components of this tension vector. Now my tension here was 80 newtons and my angle was 30 degrees. So now I can just use some trig to figure out both the x and the y, but I don't care about the y, so we're just going to focus on the x. So since I have the angle, I need the adjacent, and I have the hypotenuse, I would use cosine. So the cosine of 30 degrees is going to be the tension in the x direction divided by the 80. Or multiplying over, I get the tension in the x direction is going to be 80 times cosine 30 degrees, which gives me a tension in the x coordinate. My x component is going to be 69.28 newtons. So that's how we break it out. Now, if I wanted to know the y, I would do that as well. And if I wanted to start summing forces, I would have to do all my x's and all my y's. But we'll start easy. So let's look at another example. So let's take a look at this example. In this example, you're pushing a 40 Newton box across the floor. There's 4 newtons of friction that are acting against you in resistance, and you're pushing at 27 degrees from the horizontal. So that's measured. If you drew a horizontal right here, this would be 27 degrees. And then the force that you're applying is 60 newtons. So what are the sum of the forces in both directions? So we want to know what's the sum of the forces in the x direction and what are the sum of the forces in the y direction. So let's break this off and draw our free body diagram. So we're going to have a box and we have the force of the earth on the box, and that's equal to 40 newtons. And then we're going to have a normal. And then we're having some force that's applied like so. This is the force of U on the box. And this is 27 degrees and is equal to 60 newtons. 60 newtons. And then we have a force of friction coming back. And so my force of the surface on the box, or we just put a little f, our friction force, that should be a line, kind of got off there. Okay, so let's break this out. So we're going to do the sum of the forces in the x first. So the sum of the forces in the x. So I see that I have the frictional force, which is negative 4 newtons. I'm defining x to be that way, y to be this way, positive is to the right, positive y is up. So my friction force is negative 4 newtons. The normal and the force of the earth on the box don't have any x component, so I just need the x component of this one. So we're going to have to break that out. So let's do that here. So there it goes with the curve again. So this was 60 newtons, and then I'm going to have two components, force in the y, force in the x. This was 27 degrees. So my force in the x direction, that would be the adjacent over the hypotenuse, which is cosine. So cosine 27 equals f of x over 60. So 60 times cosine 27 equals f in the x direction. So we get the force in the x direction is going to be 53.46. So you just put that in your calculator. So my force in the x direction is 53.46, and those are all of my forces in the x. So the sum of the forces in the x direction is going to be the negative 4 plus 53.46, which would be 49.46 newtons. So that's the force that's actually being applied to move the box forward. However, a portion of the force being applied is also pushing it down. So we're going to have to add that on to my force of the earth on the box. So the sum of the forces in the y direction are going to be the force of the earth on the box, which is negative 40 newtons since it's down. And then I would need the f of y, so it's the opposite over the hypotenuse, which is sine. So I get sine of 27 is equal to the force in the y direction divided by 60. So 60 sine 27 equals the force in the y. So we get the force in the y direction is 27.24. 24 newtons. And that's downward, so that's a negative. So the force on y is negative 27.24 newtons. So we add those together, we get the sum of the forces in the y is equal to negative 67.24 newtons. So that's how we can break him out. Later we'll do some where we have to determine the resultant, or the angle, or sometimes it won't be exactly in the x. If we're pushing a billiard ball or something. But anyway, this is a good start for now.